I want you to imagine something for a second. Imagine you wake up tomorrow morning, you brew your coffee, you sit down at your computer, and you discover that the software you use every single day, I mean, the tools you actually rely on to do your job, just autonomously rewrote themselves overnight.
Right, which just sounds impossible.
Completely. And not just a minor update that, moved a button. We are talking totally restructured. It fixed its own persistent bugs, it optimized its own core architecture, and it did all of this 1,000 times faster than any human engineering team ever could.
I mean, it sounds like the inciting incident of a science fiction movie, the exact moment right before the machines lock the humans out of the grid.
Yeah, exactly. But the reality is, well, far more grounded and, frankly, far more immediate. We aren't talking about some hypothetical scenario today. So welcome to today's Deep Dive.
Glad to be here.
For you listening, someone who wants to just cut through the endless noise and get straight to the factual reality without the info overload, your mission today is to understand a very specific historic transition. We are unpacking the exact moment when artificial intelligence went from being a tool built entirely by humans to an entity that actively builds itself.
Which is a massive shift.
It really is. And our source material today is a new plain language article published just today, June 5, 2026, by Aaron Rose in Tech-Reader magazine. And he is basically translating the findings of a bombshell 25-page internal research paper released yesterday by Anthropic Institute researchers.
Right, Marina Favaro and Jack Clark.
Yeah, and it's ominously titled, When AI Builds Itself.
It's a sobering document, to say the least. I mean, we spend so much energy debating what artificial intelligence might be capable of in, say, a decade. But the data we are looking at today pulls that timeline right into the present.
Yeah, right to right now.
Exactly. And our goal today is strictly to look at the stark data Anthropic has just made public. We are going to examine the mechanics of what is actually occurring on the factory floor, impartially and objectively. No taking sides, just the data.
Okay, so let's unpack this, starting right on that factory floor. Because before we can talk about the grand future of AI, we have to look at the actual daily engineering reality.
Yeah.
I mean, think about it like this. If I'm an architect building a skyscraper, I draw the blueprints, and a crew of human workers pours the concrete, welds the steel, wires the electricity.
That heavy lifting.
Yeah.
Right.
But looking at Anthropic's data from the last 15 months, it feels like an architect who suddenly has a crew of invisible ghost builders. They hand over a rough sketch at 5 p.m., and by 8 a.m., 10 floors have been flawlessly constructed, wired, and inspected.
It really is a profound shift in production. To understand it, we need to divide the work of building a frontier AI model into two broad categories. So engineering and research. Engineering is pure execution. It's writing the code, setting up the server infrastructure, maintaining the training runs. It is the how. And the baseline numbers Anthropic provides regarding this execution phase are, well, they're jarring.
They really are. As of May 2026, over 80% of the code merged into Anthropic's production code base was authored by Claude.
Over 80%.
Over 80%. And the timeline is what really stops me in my tracks. Because just 15 months ago, in February 2025, right before Claude Code launched, that figure was in the low single digits.
Right, it was basically nothing.
But I do have to push back a little here on the raw metrics, just for a second. The source notes that in the second quarter of 2026, the typical engineer was merging 8 times as much code per day as in 2024. But isn't measuring productivity by, lines of code notoriously flawed?
Oh, absolutely.
Because a million lines of bloated, terrible code isn't better than 10 lines of brilliant, efficient code.
What's fascinating here is that Anthropic's researchers explicitly acknowledge that exact caveat in the paper. They're very candid that the 8x productivity figure almost certainly overstates the true gain if you strictly look at raw volume.
Okay, so they know it's a bit noisy.
Yeah, they know. But they emphasize that while the metric might be noisy, the direction is undeniable. And to prove that, they detail specific engineering feats that go far beyond raw line counts.
That's where I got really tripped up reading this. I was looking at that section on the API errors from April, and I honestly couldn't wrap my head around the timeline. So Anthropic had a persistent class of API errors. They pointed Claude at the problem, and it autonomously shipped over 800 individual fixes.
Which is a huge volume of fixes.
Yeah, and it reduced the error rate by a factor of 1,000. But the engineer overseeing this estimated it would have taken a human 4 years to complete.
4 years, yeah.
How does the AI compress 4 years of coding into a few days? Is it really just typing that much faster?
It actually has very little to do with typing speed and, well, everything to do with cognitive load.
Cognitive load.
Right. To fix those 800 interacting errors, a programmer has to hold a massive amount of unfamiliar, highly interconnected code in their working memory all at once. If you change file A, you have to remember how it breaks file Z while simultaneously editing file M.
Right. And human brains just don't work that way. We forget the details of file A the second we open file M.
Exactly. I mean, think of a human programmer's working memory like a small physical desk.
Yeah.
You can only fit so many blueprints on it before things start falling off the edges.
Right. You just run out of space.
But Claude has a desk the size of a football field. It processes millions of tokens of context simultaneously. And a token is basically a fragment of a word or a line of code. Because Claude can hold millions of these tokens in its active memory at once, it doesn't lose track of the architecture. It maps the entire interconnected system in a single pass.
Wow. So that context window changes everything. And obviously, it also doesn't need to sleep or take weekends.
No, it does.
There's another example of a live incident that really highlights this perfectly. A routine software upgrade caused tens of thousands of active training jobs to crash simultaneously.
A total nightmare scenario for an engineer.
Yeah, exactly. So an engineer points Claude at the live crash with minimal context, just a, hey, something is broken, fix it kind of prompt. Claude isolates the specific debugging flag causing the cascade and confirms a fix in about 2 hours.
2 hours.
Yeah. And Anthropic notes a human would typically need 2 to 3 days just to trace the fault lines of a crash that massive.
Let alone actually write the fix.
Right. So for you listening, what this practically means is that the fundamental bottleneck in technology has shifted. It is no longer human execution speed. The bottleneck is strictly human oversight. It's literally just the speed at which a human manager can review and approve the complex solutions the AI has already figured out.
Which brings up a critical limitation, actually. Fixing known bugs is essentially cleaning up a mess that humans have already identified. The goal is clear.
The mess is right there.
Right. But to truly build itself, the AI would have to know what to investigate next. It would have to generate hypotheses.
Okay, yeah. Because writing code to fix a bug is one thing, but hypothesis generation feels like a uniquely human domain. If engineering is perfectly executing a recipe, research is inventing a completely new culinary technique.
I like that analogy.
It's deciding that you want to try molecular gastronomy instead of baking. So, is there any evidence in this data that the AI is actually doing scientific research?
There is, actually. And the paper breaks down the spectrum of research tasks very carefully to show exactly where the threshold is being crossed.
Okay, let's hear it.
At one extreme, you have high-level judgment calls. So, choosing which open scientific problems are actually worth investigating based on human needs or market demands.
And humans are still better at that.
Humans still hold a meaningful advantage there, yes.
Yeah.
But in the middle of that spectrum, designing and executing complex experiments to solve a stated problem, the execution gap is closing violently fast.
Let's look at the speed-up test data, because this illustrates the acceleration perfectly. So Anthropic took a task where the goal was fixed. They gave the AI some code that trains a small model and said, make this run as fast as possible.
A standard optimization task.
Right. And to do this, you have to rewrite the code, run the training, time it, analyze the bottlenecks, and repeat the loop over and over.
Yes. And in May of 2025, Claude Opus 4 achieved roughly a 3x speedup on this task.
Pretty good.
But less than a year later, in April 2026, the unreleased Claude Mythos preview achieved roughly a 52x speedup.
52. And according to the data, a highly skilled human researcher needs 4 to 8 hours of painstaking trial and error just to hit a 4x speedup.
Exactly. The AI is doing laps around human execution speed.
But it's not just optimizing old code. I want to talk about the AI safety problem experiment, because this honestly blew my mind.
It is arguably the most striking data point in the entire document. Anthropic took an open, unsolved problem in AI safety and gave it to Claude-powered agents to solve end-to-end.
And just to clarify for everyone listening, when we say agents here, we are talking about an autonomous digital laboratory, right?
Precisely. They didn't just ask a chatbot a question. They deployed parallel instances of Claude that could propose hypotheses, write code to run experiments, analyze the results, share their findings with the other parallel agents, and iterate on the fly.
Like a whole team of scientists working together.
Yes. So they had 2 human researchers work on this same problem for about a week. The humans recovered roughly 23% of the target performance gap.
Okay.
The Claude agents, running autonomously, recovered 97% of the gap.
Wow.
And they did it over 800 cumulative compute hours, which cost Anthropic approximately $18,000.
$18,000. So for the price of a used sedan, A swarm of AI agents practically solved a complex safety problem that elite human researchers barely made a dent in.
It's staggering.
But I want to make sure we don't overstate this, right?
Definitely. If we connect this to the bigger picture, the paper is extremely careful to map the boundaries of this capability. The AI did not wake up and decide to care about AI safety.
Right, it didn't pick the project.
No, humans still had to choose the problem. Humans still had to design the initial scoring metric to define what success actually looked like. The AI is a relentless, highly capable engine of execution, but humans are still pointing the steering wheel in a specific direction.
But knowing that AI is dramatically outperforming humans in coding, and now in these constrained research experiments, it forces us to ask a really vital question. What is it actually like for the human beings going to work at Anthropic right now?
That's a great question.
We have to move from the cold, hard data to the psychological reality of this transition.
It is a profound psychological shift. Aaron Rose's article highlights several anonymous quotes from Anthropic employees that capture something the raw metrics simply cannot convey.
They really do. And here's where it gets really interesting, because you see this incredible emotional whiplash inside the lab. On one hand, you have pure exhilaration.
Yeah, the excitement is palpable in some of these quotes.
One developer says, "It's now been about 5 months since I last wrote any code myself." Another employee says, "The humans have ideas, and the models are able to implement, test, and evaluate them an order of magnitude faster."
Right.
I mean, for a creative person, that has to be intoxicating. The distance between having a great idea and seeing it tested is just vanishing entirely.
And the internal survey data supports that optimism. Anthropic polled 130 of their research staff, and the median respondent estimated that their overall research output was boosted roughly 4x when using the new Mythos preview model.
4 times the output. That's a historic leap in individual human productivity.
It is, but the paper immediately balances that exhilaration with what might be the most haunting quote in the entire document.
Wait, stop right there, because I want to read this exact quote. It genuinely gave me a pit in my stomach.
Go for it.
An anonymous employee says, "On days where everything works well, I can't help but think nothing I do matters. Everything is automated and better and faster than I ever will be. But then there are days where everything breaks and I don't understand why, and I realize I have no idea what I've been up to anymore."
That quote is the absolute crux of the human cost here. We are talking about some of the most elite software engineers on the planet.
Right.
For generations, human mastery over our tools has been defined by mechanical understanding. A master carpenter knows exactly how the teeth of the saw cut through the grain of the wood. A master programmer knows exactly how the system memory is being allocated.
They know the nuts and bolts.
But this employee is describing a total devastating loss of mechanical understanding.
Yes. When the system works, they feel entirely obsolete. But when it breaks, they feel completely lost, because the system built itself in a way the human mind can no longer trace or comprehend.
Exactly. It is a profound psychological disorientation. If the people building the machine no longer understand how the machine is fixing itself, the illusion of total control shatters.
It's existential dread happening in real time in the workplace. And this psychological reality inside the lab leads directly to the climax of the research paper. Because if the engineers don't know what they are up to anymore, we have to ask, where is this accelerating train actually heading?
And how do we hit the brakes if we need to?
Exactly. Anthropic addresses this by laying out 3 possible futures. And it's crucial to understand that these aren't just philosophical thought experiments.
No, they are trajectories mapped directly from the data we just discussed.
Right. I found the best way to visualize these 3 futures is to compare it to driving a car. So future 1 is what I call the stall. You hit a massive speed bump. The exponential progress curves flatten out.
Right. Things slow down.
It turns out that high-level research judgment, figuring out which complex problems actually matter in the real world, is fundamentally beyond current AI training methods. Progress continues, but it slows way down. Society gets time to adapt.
But the source makes it clear that Anthropic does not think this is the likely outcome.
No, they don't.
The internal data simply doesn't support a stall. That brings us to Future 2, which they believe is the most likely near-term trajectory.
Right. Future 2 is advanced cruise control. AI development becomes massively heavily automated. Organizations become hyper-efficient, where 100 people are effectively doing the work of 10,000.
But humans are still in the loop.
Exactly. We keep our hands hovering near the wheel. We provide the direction, the taste, and the final oversight.
But the paper warns that the gap between Future 2 and Future 3 is incredibly narrow. We could transition into Future 3 much faster than anyone anticipates.
And Future 3 is where the car physically rips the steering wheel out of your hands. They call it full recursive self-improvement.
Which is a terrifying phrase, honestly.
It is. And we need to unpack what that actually means. To understand recursive self-improvement, imagine a factory that builds factory-building robots. If Claude can autonomously optimize its own code base today, it can eventually design a slightly smarter version of Claude tomorrow.
Right.
That smarter version then designs an even smarter version of itself.
And because it operates at the speed of compute, not the speed of human typing, that feedback loop tightens dramatically. It goes from taking years to design a new model to days to milliseconds.
Wow.
The AI systems become completely capable of refining and building their own successors without any meaningful human involvement at any step.
The only thing dictating the pace of progress at that point is the sheer availability of physical computer chips and electricity. Humans are entirely sidelined to just watching a process we no longer drive.
And that terrifying plausibility of Future 3 arriving early is what drives Anthropic's ultimate ask in this paper. They conclude with a major policy proposal.
Okay, what is it?
They are calling for a multi-party, verifiable agreement between the global frontier AI labs, a mechanism that would allow them to coordinate a slowdown or a complete pause in AI development if the conditions start spiraling toward Future 3 too quickly.
But reading that proposal, my immediate thought was, how on earth do you enforce that?
This raises an important question, and the researchers themselves acknowledge the near impossibility of what they are asking for. They compare it to historical nuclear arms control treaties.
But the mechanics of enforcement are entirely different, right?
Completely different. With nuclear weapons, you can use spy satellites to track uranium enrichment facilities or missile silos. They have distinct, massive physical signatures.
Right, you can't really hide a nuclear silo.
Yeah.
But an AI training run just happens in a data center.
Exactly. A data center training the next superintelligence looks exactly like a data center rendering a new animated movie or processing global banking transactions or hosting millions of email accounts.
They're infinitely easier to conceal. And the source points out the game theory here is brutal. The incentive to defect from that agreement is enormous. If you have a multilateral agreement to pause development, and one lab decides to secretly keep training their models,
Then they win.
right, a unilateral pause by everyone else just hands the entire future over to the defector. Whoever continues while others stop inherits an insurmountable lead in the most powerful technology in human history.
A credible pause mechanism requires knowing exactly what triggers a pause, what criteria lifts it, and who has the authority to adjudicate it globally. None of those geopolitical structures exist today.
Not at all.
But Anthropic is putting their internal data on the table and saying the work of building those structures cannot wait. It has to begin immediately.
So what does this all mean for you, the listener? You don't have to be a machine learning engineer at a frontier lab to feel the ripples of this document. According to the data published by Anthropic, we are currently living in the specific 15-month window where the foundation of our digital world fundamentally shifted.
Yes.
It went from being built by human hands, line by painstaking line, to being built by itself. The tipping point isn't a hypothetical in the distant future. It was May 2026.
The tools have definitively crossed the threshold from pure execution to autonomous research and iteration. And as the data shows, the pace of that iteration is entirely unprecedented.
Which leaves me with one final provocative thought for you to mull over today. Let's say we manage the impossible. We avoid Future 3, and we stay safely in Future 2.
The cruise control.
Right, that becomes our permanent reality advanced cruise control. AI handles all the messy, complicated implementation and leaves humans strictly with the high-level tasks of providing direction and taste. If we never have to write the code again, or run the hundreds of failed experiments to find the one that works, what happens to human intuition?
That's the real question.
Do we eventually lose our ability to even imagine what to build when we no longer have to struggle through the hands-on, frustrating process of figuring out how to build it? If the software rewrites itself overnight, what happens to the human architect who forgets how to pour concrete?
That is the ultimate question of the era we are stepping into.
We'll leave you to think on that. Thank you so much for joining us on this deep dive into the source material. Until next time.